the great nothing, the terrifying mystery of cosmic voids. Across the vast and glittering canvas of the universe, galaxies swirl in dazzling constellations, nebulae shimmer like celestial brushstrokes, and stars blaze in every direction. Yet in this seemingly endless ocean of light, there are also regions of pure darkness, places where nothing exists, not because our instruments can't detect anything there, but because there is literally almost nothing to detect. These aren't just empty regions between galaxies. These are cosmic voids, immense silent deserts of space, hundreds of millions of light years across, where matter has seemingly vanished, discovered decades ago, but still not fully understood. These voids defy what we thought we knew about the structure of the cosmos. Now, new research has begun to uncover shocking possibilities. Could these regions of nothingness be relics of universe-shaping catastrophes? Could they be scars from collisions between entire universes? Or are they portals into a deeper level of reality governed by unknown forces? The answers are as fascinating as they are terrifying. The mystery of cosmic emptiness. When we think of the universe, we imagine it teeming with stars, planets, galaxies, and perhaps even life. But space isn't evenly filled with matter. It's actually structured like a web, a vast cosmic lattice of filaments made of galaxies and dark matter, stretching across billions of light years. Between the strands of this cosmic web are enormous empty regions, the voids. These voids are not small gaps. They are expanses so vast that if you could travel at the speed of light, 300,000 kilometers per second, it would still take you hundreds of millions of years to cross even one of them. One of the most famous examples is the Boötes Void, discovered in 1981 by astronomer Robert Kirshner, often referred to as a great nothing. This void spans an unimaginable 330 million light years. When astronomers first observed it, they were stunned. In a volume of space where billions of galaxies should exist, they found just a handful of isolated galaxies, like tiny lanterns flickering alone in a sea of total blackness. Since then, other voids have been discovered, some even larger, such as the Eridanus supervoid and the Northern Local Void. Today, thousands of such voids are known to exist, and together they make up the majority of the volume of the universe. That's right, what we think of as a universe, the glowing galaxies, stars, and nebulas, actually occupy only 10 to 20% of the cosmos. The rest is void, the science of nothing. So what causes these yawning chasms in space? And why are they so enormous? According to conventional cosmology, the early universe was almost uniform, filled with a nearly even distribution of matter. But over time, small differences in density caused matter to clump together under gravity, forming galaxies and clusters, while the spaces in between became increasingly empty. This gravitational self-sorting is one explanation for the formation of voids. Matter collapses into dense filaments and nodes, and the empty spaces grow wider and emptier. But this process doesn't fully explain the sheer scale of the largest voids, nor does it explain why some voids contain strange geometrical features, like cylindrical shells and sheets of galaxies, or why galaxies found inside voids are unusually isolated and evolved differently from their more crowded cousins. Some researchers now believe that voids may not just be natural byproducts of cosmic evolution. They could be cosmic scars, left behind by events so violent and fundamental that they tore holes in the very fabric of space-time itself. Ghost galaxies in a wasteland. Even more unsettling is the fact that voids aren't completely empty. They often contain a few lone galaxies, wandering like ghost ships in a cosmic ocean. These galaxies exist in profound isolation, far from the gravitational pull of any galactic neighbor. And that isolation has consequences. Galaxies and voids evolve more slowly. They have fewer gravitational interactions, fewer collisions, and fewer opportunities to acquire new matter for star formation. They appear to be living fossils, remnants of an earlier time in the universe. Their stories frozen in time. What's eerie is that their presence highlights just how abnormally empty these voids are. The galaxies aren't just randomly distributed. They're the exception, the flickering lights in a near-absolute darkness. Dark energy, dark matter, and the shape of nothing. Whenever we speak of cosmic emptiness, we cannot avoid two of the most mysterious components of the universe, dark matter and dark energy. Dark matter is an invisible form of matter that doesn't emit or absorb light, but exerts gravitational pull. It makes up about 27% of the universe's energy density. Dark energy, even more enigmatic, is a force or property thought to be responsible for the accelerating expansion of the universe, and comprises about 68% of the total. Together, these dark components dominate the cosmos. Visible matter, the stars, planets, and galaxies we can see, makes up less than 5%. Some scientists believe that voids may be shaped or expanded by dark energy, and that their distribution may offer clues to its nature. Others suspect that unknown configurations of dark matter could help explain why these voids exist in such unlikely abundance and size. What if we lived in a void? It's hard to imagine how our understanding of the universe would have developed if Earth had been located inside one of these vast voids. But imagine this. In the 1920s, Edwin Hubble observed galaxies beyond our own and discovered that the universe is expanding. His observations transformed modern cosmology. But if Hubble had lived on a planet inside a void, there would have been no nearby galaxies to observe. His telescopes might have revealed only darkness. He might have concluded that the Milky Way was the entire universe. In fact, it's likely that a civilization living inside a deep void would develop an entirely different model of cosmology. The illusion of emptiness would dominate their view of the cosmos, and they might never suspect the presence of the vibrant galactic web just beyond their observational reach.
The multiverse collision theory. Here's where the mystery deepens even further, and enters the realm of the speculative, the controversial, and the extraordinary. Some theoretical physicists propose that these voids may be the aftershocks of collisions between entire universes. In certain models of the multiverse, our universe is just one bubble in a vast multiverse of countless other universes, each with its own laws of physics. Occasionally, these bubbles might collide, and such a collision could leave behind a vast region of disturbed spacetime, a void. There is even some evidence to support this. The cold spot in the cosmic microwave background radiation, essentially a colder-than-average patch in the afterglow of the Big Bang, has been linked by some to a possible collision with another universe. This cold spot coincides with the Eridanus supervoid, one of the largest known cosmic voids. The idea is still highly controversial. Many cosmologists favor more conventional explanations involving gravitational clustering. But the multiverse theory, once considered fringe, is gaining traction in theoretical physics, and voids may be one of its first observable clues. The universe isn't full. It's mostly empty. When we picture the universe, we usually imagine a brilliant, dynamic expanse filled with stars and galaxies. But this view is misleading. In reality, the cosmos is overwhelmingly empty. Void regions may contain some of the most profound secrets of the universe. They are quiet, subtle, and hauntingly still, but they may offer clues to questions like, what is dark energy? What lies beyond our observable universe? Did our universe collide with another? Are voids natural features, or cosmic scars? Even more fascinating is the possibility that the absence of something can reveal more than its presence. Just as an archaeologist studies the gaps in a ruined wall to understand the structure that once was, cosmologists are now studying voids to understand the unseen structure of the universe itself. The final frontier. Nothingness itself. In the end, these cosmic voids challenge not just our understanding of the cosmos, but our very intuition about what existence means. They force us to consider that emptiness is not just the absence of matter, but possibly the key to understanding the whole. Perhaps, as some suggest, voids are not accidents but an integral part of cosmic evolution. Perhaps they are necessary for the formation of structure, the propagation of light, and the flow of time. Or perhaps they are reminders that the universe, for all its beauty and light, is also terrifyingly vast, indifferent, and silent.